Hello and welcome everyone to this basic electronics module sessions. Now I know that many of you have many times wondered about how does the fan works or how does the LED glows or how does your TV or television starts. So these are some things which we are going to clear in this sessions. So this is the very first session of our basic electronics module, and I hope and I pray that you'll learn so many things in this module. So let us first start our first module and the very first session of this module. So this is going to be the introduction video. So in this session you are going to learn about the basics of electronics. What kind of things it relates, what is voltage, what is current, and so many different things. Now, this is a table of content. So, these are the four things which we are going to mainly cover in this session. The first category is introduction. Second is the semiconductors. Third one is voltage, and after that, we will see the current. Let us first start with the introduction. So, in this session, we will learn the basic concepts of basic electronics, like what is basic electronics, which are the devices that falls under this category, and their advantages, disadvantages, and applications. So, now electronics is about manipulating electricity to accomplish a particular task and is very much a hands-on endeavor. Since the result of building electronic circuit is usually a device that performs a task, this hands-on aspect should be self-relevant. Now, in this the first session, we are going to cover the introduction, advantages, disadvantages, examples, and applications. So, first, let us start at this session with the definition or the concept clearance of basic electronics. So, this term basic electronics is mainly formed by two individual words which are basic and then electronics. Now, the electronics is derived from the word electrons. Now, electronics is a branch of a physics that deals with the theory and use of devices in which electrons travel through a vacuum, gas, or a semiconductor or in any medium. The motion of electrons take place under the influence of applied electric and or magnetic field. Means under the electric or magnetic field, the electrons are getting motion. All circuits need to have three basic elements. Now, when you are going to build a circuit, you should have minimum these three elements. The first element is a voltage source, the second one is conducting path, and the third one is the load. Now, the voltage source, such as a battery, is needed in order to cause the current to flow through the circuit. In addition, there needs to be a conductive path through which your current will flow, and after that, a load, or you can say bulb or anything like that, which is going to illuminate or start. Some of the most commonly used electronic components are resistors, capacitors, inductors, diodes, LEDs, transistors, crystals, and oscillators. And electromechanical components are like relays, switches, IC, and connectors. So, after seeing the definition of electronics, let us see the advantages and disadvantages of this kind of gadgets or circuits. Now, this gadgets or electronics branch has many advantages. Like at first, easy access to information. Now, due to this technology advancement and the gadgets of electronics, you have any kind of information. You can have any kind of information anywhere, anytime. Now, also, it encourages innovation and creativity, improved communication, convenience of traveling, improved housing and lifestyle, improved entertainment, efficiency and productivity, and convenience in education. Now, because of this technology advancement and different kinds of new gadgets, you can have everything in your hands. Like for example, in education sector, now we have projectors, tablets, computers, so students can watch online videos and learn themselves. These are the advantages. Now let us see the disadvantages. As we know that anything has its own pros and cons. Similarly, this basic electronics has the disadvantages also. Now because of this very advancement or the different kinds of new gadgets, it has increased loneliness. Also, it causes many job loss, more competency. People builds world destruction weapons. Also, electronic devices can improve communication, but they are also blamed for social issues. So these are the disadvantages of this kind of technology advancements. After that, let's move on to the applications. So as you can see in this picture, these are the basic electronics components, the components which falls under the category of basic electronics, and we know many of them, and many of them we work on day to day basis. So these are the devices we see everywhere around us: mobile phone, computer or laptop, tablets or iPads, electronic watches, Bluetooth speaker, digital camera, television, music player, gaming consoles, electronic toys, electronic bell, USB lights, and amplifier. So these are some of examples of basic electronics gadgets. After seeing the basic concept, now let's move forward with different materials and what are the semiconductors. So this is the second category of our today's session. So let's see what are the different materials we have. See, as we already know, any material are categorized or divided in three main parts. First one is conductor, the second one is semiconductor, and thereafter we have insulators. See, conductors are the materials which allows electrons or current to flow through them. So the conductors are the materials that permit the flow of electrons. For example, gold, silver, copper, aluminium. These are the conductors which allows the flow of current through them. Now in conductors, the gap between the conduction band and valence band is negligible, or you can say minimum. Now the materials that blocks the flow of electrons are called as insulators. So insulators are the materials which blocks the flow of current or which does not allow the current to flow through them. So these are the rubbers, glasses, Teflon and mica. So these are the some of our examples of insulators. So in insulator what happens is in conduction band and in valence band the gap between both the bands are very high. So in insulator the conduction band and valence band are highly gapped. Whereas in semiconductors, these are the materials whose conductivity falls between those of conductors and insulators. So they are falls between conductors and insulators. So these some of the examples of this kind of semiconductor materials are silicon and germanium. So the conduction band and valence band has small energy gap, whereas in conductors there is a negligible energy gap, whereas in insulators the conduction band and valence band has a large energy gap. So these are the difference between them. So insulators you can easily see them in the different current protection devices like in the gloves, or you can say the coatings. Now these are the semiconductors. So semiconductors are used for manufacturing of different kinds of ICs or resistors, and these are the conductors which are used to make different kinds of cables. So levels of conductivity are the main difference between conductors, semiconductors and insulators. Conductors display high conductivity, means conductors are named because they have high conductivity, which means they allow energy such as electricity, heat or sound to easily flow through them. Whereas in semiconductors they allow a moderate flow, whereas in insulators they exhibit low conductivity. So these are the semiconductor devices in which the semiconductor materials are used. So op-amp, resistor, capacitors, diodes, transistors and different kinds of ICs are made from semiconductor materials. This semiconductor are core and building blocks of these electronic gadgets and devices. Now the global semiconductor market size was 527.88 billion US dollars in 2021 and is projected to grow from US dollars 573.44 billion in 2022 to US dollars 1380.79 billion in 2029. So different semiconducting materials have different properties from which they are used to construct different types of you can say equipments or parts. So the different kinds of category or you can say different properties of semiconductor materials are this. First one is light emission. In certain semiconductors, excited electrons can relax by emitting light instead of producing heat. So this kind of semiconductors are used in the construction of light emitting diode or you can say LED and fluorescent quantum dots. Now, whereas in high thermal conductivity materials, these kind of semiconductors with high thermal conductivity can be used for heat dissipation and improving thermal management of electronics. Third one is thermal energy conversion. Semiconductors, this kind of semiconductors have large thermoelectric power factors, making them useful in thermoelectric generators as well as high thermoelectric figures of merit, making them useful in thermoelectric coolers. When there is contact or a touch on the surface of the touch sensor, it acts like a closed switch and allows the current to flow through it. When the contact is released, it acts similar to the open switch and hence there is no flow of current. So these were some properties of different semiconductor materials. Now let us see the applications of these semiconductors. So personal computers and televisions, you can see them also in industrial and manufacturing uses, also in bank ATMs, automobile, making of electronic gadgets, advanced mechanical devices. So these are the application area where semiconductor materials are widely used. So these are the widespread applications of semiconductor materials. You can see this kind of devices in telephone, tablets, smartphones, PC, automotive surveillance camera, train, industrial robots, vending machine, solar cells, washing machine, micro oven, air conditioning system, gaming console, digital camera, and TV. Now let's move forward to our third category of this session, which is voltage. So in this section, you will learn about the basic building blocks of electronic, which is voltage, its SI unit, and what is the formula of voltage. So in this image, you can see that it has some kind of a pipe and current flowing through it. So we are going to understand the concept of voltage using this. Now, what is voltage? So you can refer a voltage as a pressure or you can say force. So whenever there is a pressure or the height difference between 2 points, you can see that the water can flow through it. But what if it has no height difference or no pressure difference? There will be no flow of water, right? So yes, you can see or you can understand this voltage as a force or pressure. Voltage is the total work required to move a unit of charge between 2 points in a static electric field. So you can assume it as a static electric field, and these are the 2 points. This is the first one and this is the another one. So these are the 2 points, and difference between these 2 points can create a force or pressure because of which a charge of unit charge can move. Voltage is also referred to as electric potential difference, electric pressure, or electric tension. It is the difference in the electric potential between 2 points. Now, between, or you can say between these 2 points, if there is a potential difference, then because of this potential difference, your current will flow. It is the work done in moving a charge from one pole to another through a wire. So you can see it as a voltage source. This is the conducting path. I hope you remember from our first basic electronics concept or definition. For a circuit, you should have three main elements. The first one is voltage, the another one is conducting path, which is this a wire, a cable, and third one is your load. So here, as you can see, is this is your voltage source, this is your conducting path or cable, and this is the load. So whenever there will be a potential difference between 2 points, this is the work done in moving charge from one pole to another pole. That would be your voltage. So in the mathematical representation, you can see voltage, or you can refer voltage as the multiplication of your current and load. So voltage is nothing but voltage is equals to I into R. So current multiplied by your load. So here V is voltage, I is current, and R is resistance. Now see, as you can see in the image, these are the different kind of voltage sources which provides as a power or energy to perform any task. See, for example, these are the cells, right? So without cell, you cannot operate your remote control, right? So in your remote control, these cells are performing or are the basic elements for a circuit to complete. So these are the cells which are going to provide power to your circuit, and because of which you can perform the another task. A voltage source is a two terminal device which can maintain a fixed voltage. An ideal voltage source can maintain the fixed voltage independent of the load resistance or the output current. Means if there is any changes in load or current, there would be no change in the voltage, and hence it is named as ideal voltage. However, a real world voltage source cannot supply unlimited current. So, the SI unit for your voltage is volts. Please to remember that the SI unit of voltage is volts and it is denoted by capital V. Let us see the three cell battery. So in what happens in this kind of cell is three cells are connected together, and as you can see here, you have total four outputs, or you can say four output pins, right? Here you have different kinds of wire, different colored wires. One is black, the another one is white, then red, and then orange. Now particularly this black wire suggests the ground connection. Then after there is 4 volts. Using this and this you can have 4 volts. Using this ground and 4-volt pin you can have 4 volts. If you require 8 volts, then you can connect your circuit between this point and this point. first and third, you will have 8 voltages. If you require more than 8 voltages, then you can use this last pin, which will provide you with 12 volts. So this is ground. Connecting this with between this and this pin, you will have 12 volts. So here black wire is for ground and 3 cells are connected in series. We can use 3 different voltages, which are 4 volts, 8 volts and 12 volts as per our requirement. This battery is used to provide voltages up to 12 volts in toys or small machines. Now let us move forward to our last and fourth category of this session, which is current. So in this section you will learn about the another basic building block of electronics, which is current, and you will also see the SI units and formula. First, we also are going to use the similar example to understand the basic concept of current. In the previous voltage category, we have seen this kind of tube. Now, in this section, we have two different pipes. See, as seen in the image, you can see that the volume, or you can say the diameter of this pipe is more, while the diameter of this pipe is small. Hence the water coming out of this particular section is less compared to this, because this pipe has a diameter more than it has. So the quantity of water flows through here is less than the water flows through here. So the volt amount of water coming out of this session or this section is more compared to this, because of this gap, because the gap over here is high, whereas the gap over here is less. So electric current is nothing but a rate of flow of electrons in a conductor. So rate of flow of electrons is denoted by current. So whenever there is a flow of current, that is nothing but flow of electrons, that is nothing but current. When the potential difference is applied across a wire, then loosely attached free electrons will start moving towards the positive terminal of the cell. So these are the free electrons which moves, and because of their motion you have current in your circuit. This continuous flow of electrons makes the existence of the electric current. The mathematical representation of voltage we know is V is equals to IR. So from that equation you can have the particular representation or particular formula for current I, which is going to be voltage divided by resistance. We have V is equals to IR, and from that particular formula we can have I or current as the voltage divided by the resistance. Now here I is current, V is voltage, and R is resistance. So as we have two different conventions, this is the conventional current flow. We have this plus to minus, but in real the electrons flows from this to this. But in conventional method, we use the flow of current from positive to the negative. The SI unit of this current is ampere and is denoted by capital A. Now formula for 1 ampere current is going to be the 1 coulomb divided by 1 second. So 1 coulomb of charge per second is per 1 ampere charge. So as we know that current is the flow of free electrons. Now this kind of current has two types. So current has two different types, which is AC and DC. So AC, the full form of AC is alternating current, whereas DC stands for direct current. So in alternating current, as you can see from its name, that the kind of current which alters or which changes its magnitude, right? From this graph, you can see here, we have a graph between magnitude and time. Okay, so what you can see here is a sinusoidal wave, right? Sinusoidal wave means the thing or the magnitude or the altitude changing with time, means it is not constant. So here what is changing? So here with time the magnitude is changing. Magnitude of what? Magnitude of current. So magnitude of current is changing with time, hence this kind of current is called as alternating current. So at particular this point the time is 0 and also the magnitude of current is 0. As the time increases, you can see that the magnitude of current is increasing up to this point, right? Now, up to this point, you can say that this is the higher or maximum amount, right? From this, you can see the time is increasing, but the magnitude of current is decreasing, right? Here, from here to here, your magnitude of current is increasing, where from here to here, the magnitude of current is decreasing. After this point, you can see the value of current is not going here. It is going in the negative direction and it is reaching to its maximum, right? After some time, it is also increasing. See, it is increasing and becoming zero again, right? And here your first cycle is completed. After that, your cycle will be repeated. It will increase, go will go to its maximum positive. Again, it decrease and go to zero. Again, it will increase in negative. Then it will increase, will reach to zero, and the cycle will itself be repeated. So here we have two maximums. First is positive maximum and the negative maximum. And here it is 0 and here also it is 0. So here the magnitude of current changes continuously. So you can see at this point the magnitude of current is different. Also for this point the magnitude is different. For this point the magnitude of current is different. For this point of time your value of current is different. So at each and every point the value or the magnitude of current is changing. So it is continuously changing. A sine curve or cosine curve represents the current. Alternate current is generally used to power applications because it can be transformed from a higher voltage level to a lower voltage level. So, the application of this kind of alternating currents you can majorly see in large household appliances like refrigerators and dishwashers. Also, this kind of current is provided at residential and commercial area. Now, our second type of current is direct current. As you can see from its name, that direct current means there is no alteration of magnitude or no alteration of current. In this graph, you can see that there is only a one constant line. This is the one straight line. Here, with time, time is increasing. Similarly, the magnitude of your current is same. With time, there is no change in magnitude. For 0, it is same. For maximum time, it is the same. The magnitude of your current isn't changing. It is constant from this to this. So with time, The change of magnitude is nothing. So with time, it is staying constant. So the current whose value does not change with time means it stays constant always. Here, the magnitude of current remains constant and the current flows in one direction only. Direct current can also be obtained from an alternating power supply with uses of rectifiers. So using a rectifier, you can change the direct current, you can change the alternating current into direct current. It can be converted into an alternating current with the use of inverter. So direct current can be changed or converted into an alternating current using inventor or a set of motor generator. Now the application area of this kind of direct current are most of the household appliances. So most of the small household appliances and consumer electronics uses direct current, such as light bulbs, chargers, mobile phones and laptops. So these are the application area where your direct current is mainly used. So that was all about first session or our first lecture. Thank you so much guys.